Today we're going to be looking at the standard normal distribution model, and what we're doing essentially is moving from our discussion of discrete probability distribution models from Friday to continuous population probability distribution models. So remember that for a discrete probability distribution model, we could get the probability of being within a certain value by reading along the vertical axis. For a continuous model, what we're going to be looking at again is the area between underneath the curve between two values. Okay, so to get started with that, we're going to be looking at what we call the standard normal distribution. So the standard normal distribution is used because there are many variables that seem to have a symmetric bell-shaped curve to them. We have tables that we will be using to calculate probabilities based on a standard normal distribution. The center of our standard normal distribution has a value of 0. Okay, so the mean is 0, and the standard deviation is 1. And so what that means is that we have this horizontal axis, which we refer to as the z-score, and it increases in increments of 1. We'll talk more about this over the next couple days, but it turns out that almost all of the values will have z-scores between -3 and 3. Okay. Also, the area underneath the standard normal curve has a value of 1. And so that means that the area to the right of center has an area of 0.5, and the area to the left of center also has an area of 0.5. So next comes the skill in calculating probabilities using z-scores. We're going to be going back and forth to our chart a lot. Okay. For positive z-scores, we're going to be using the second page of our chart. For negative z-scores, we're going to be using the first page. If we look at example A here, we want to find out the area between 0 and 1.2. This corresponds to calculating the probability of having a z-score between 0 and 1.2. We can put those values on our chart if we like. So, if we look up on our chart, again, positive z values are on the second page. We see that a z value of 1.2 has a value of 0.8849 associated with it. So the probability that z is less than 1.20 is 0.8849. Now, we don't want the probability that z is strictly less than 1.2. We want the probability that z is between 0 and 1.2. So that first thing that we found was from the chart, right? The probability that z is between 0 and 1.2, though, we can easily calculate because we know the area to the left of 0 is 0.5. So we take our 0.8849 and subtract 0.5 to get an answer of 0.3849. The probability of having a z-score between 0 and 1.2 is equal to 0.3849. If I want to find the area between negative 1.2 and 0. All right. I'll use my values from the chart a little bit differently. Again, if I look at what happens for negative values and the graph that's being shown, is I see that it gives me the values from the far left end up into my Z value that I'm looking up. So when I look up a Z value of negative 1.2, I get a value of 0.1151. But that is left of the Z value that I'm looking at. So 0.1151 is less, is the probability that Z is less than negative 1.20 is 0.1151. Again, I know the total area on the left-hand side is 0.5. So that shaded miss area, that is what I'm trying to find, which is the probability that Z is between negative 1.2 and 0, I could find by taking 0.5 and 0.1151, and I get 0.3849. And you might say to yourself at this point, but Vicki, this is the exact same as what we got in the last question. And it's true because of the symmetric nature of the curve. It is the same value. It should be the same answer. And so you could actually calculate it either way as long as it makes sense to you. Okay? So if we're finding out the value, though, between two different Z values, often we're going to have to look something up on the chart, maybe looking two things up on the chart, and then doing some addition or subtraction. We're going to think about how those areas combine, what's given on the chart, and what we're asked to find. And again, if you look at the picture on the chart for the Z values, it's always the area from the left up into a particular Z value. So as we get closer and closer to a value of 0, then the probabilities become closer and closer to 0.5. For any of our positive values, they start at 0.5 and increase from there. As they get larger and larger, they get closer and closer to 1. Okay. So let's do another example. If I want to find the area under the curve between a Z value of negative 1.5 and a Z value of 1.23, again, I can think about where those lie on our curve. So the yellow isn't actually very easy to see at all, although it's color coded. I'm going to go over that again with black. Okay. And so what I can find out from my chart is I can find out the probability that Z is less than negative 1.5 by looking up 1.5 on the Z chart. Negative values on the first page. Negative 1.5 has a value of, right there, it has a value of 0.0668. And if I look up a Z value of 1.23, again, I'm going to get that cumulative probability up to a Z score of 1.23, but not including it. Okay, so that's 0.8907. And if I want to find the probability that Z is between negative 1.5 and 1.23, then I'm going to find the difference in those area values. Don't forget your 0. Again, probabilities, these are all reported accurate to 4 decimal places. And so we can just write down our final answer. It's 0.8239. Okay. So if you're looking up between two values, we have to do this bit of subtraction. Not all questions, though, require this work. It depends on what the question is we're being asked. If we want to find the area less than negative 2.13, right? Or the probability that z is less than negative 2.13. Because we're finding an area left of our z values, all we have to do is look up that z value on our chart. Negative 2.13. Negative 2.13. Notice the first negative 2.1 is given in the first column, and then to find the second decimal place, right? I look along the top column or the top row, I find the 0.03. If I follow that down, then I get a value. Negative 2.13 has a value of 0.0166. Okay? And that's my answer. There's no other work to do. The area less than negative 2.13 is 0.0166. The probability that has a value of less than negative 1.213 is 0.0166. The probability that any of my data values fall more than 2.13 standard deviations below the mean is 0.0166. That value can be interpreted all those different ways. Okay. And same, if I want to find the area less than 0.87, this is a positive z value, but it's still a less than type question. And so all I have to do is look up that z value on my chart. 0.87. Oops, next one down. 0.8078. And that's my answer. Feel free to pause now, skip over some of the word problems, and we'll talk about drawing those pictures in a little bit. And you might want to try some of the first set of homework questions, okay? The answers to the homework questions are at the bottom of the page. And so if you have any questions, let me know. I'll continue with a second video that goes over some of the word problems that we might encounter related and how we can use the Z scores and the tables to solve those.